Okay.
And then did you want to get rid of the thingy? I think if you go more and then go high, floating meeting controls, that's one.
Yeah,
Right.
great. Well,
Thanks, Tracy. Thanks everyone for coming. Yeah, I'm Emma and I'll be talking about how marine citizen science experiences influence stewardship behaviours. Which one? Oh yeah. Great, thank you. Okay. So we're on the Great Barrier Reef. We're helping scientists to understand the health of the coral, and we're also interacting with a group of other people who've come along today to join this marine citizen science experience. We're feeling a sense of wonder and awe at the beauty of the reef. We're feeling connected to nature and we're feeling energized. We're also having a range of social interactions, talking to other people about things we can do to help the reef. We're practicing behaviours and we're taking action with others. Fast forward, you're on the beach, you see some plastic, do you pick it up? So what I'm interested in studying is within this context of marine citizen science experiences, how these nature experiences of wonder or connection to nature and these social experiences of connecting with other people, practicing behaviours and talking to others about those behaviours, and how do they interact differently? And the outcome being willingness to adopt stewardship behaviours such as picking up plastic or attending a rally. So in the context of Australia, stewardship is mentioned in our strategy for nature, and it's also talked about in our state of environment report. And they have a specific focus on environmental citizen science programs, and this makes the link between participating in a program and expecting that people will then take action for nature. So we're trying to understand this relationship and see if there is a relationship there, or and if so, what parts of those experiences are important. So what can people do? There's a whole range of stewardship behaviours that people could adopt for the reef, from restoring ecosystems to advocating for nature. And all of these behaviours can help us with conservation solutions and conservation outcomes. But if we want to promote stewardship behaviours, we need to understand what influences those behaviours. And so this study looks at how those marine citizen science experiences influence that willingness to adopt ocean conservation. And the research design was based around this Reef Blitz program. That's an annual event that brings together multiple citizen science programs to help Queensland communities collect relevant information for reef health. So in our survey, which was an intercept survey with participants of these events, we asked them about the experiences that they had on the day, about the nature experiences and the social experiences, as well as a range of outcome variables around their willingness to do different types of ocean conservation behaviours. And those range of behaviours fell into two key well, through a factor analysis, they came out as two key areas. One was adopting a personal behaviour yourself, and the other one was encouraging others to adopt a behaviour. We had a range of age in our sample. About half was female, half identified as male, and 63% were regular visitors to the reef. So the analysis we used for this study was a regression model with interactions. So the interactions were looking at how the experiences vary according to environmental identity and past group involvement. So these nature experiences that we measured in the survey included feeling energized by being out in nature, feeling more connected to it, and also seeing and experiencing nature in a way that made conservation issues real. The social experiences were working with others, observing others, having conversations with others, and learning from talking with other people. The stewardship behaviours, so the personal behaviours that people could do themselves, included attending a cleanup event, reducing plastic use, and picking up discarded plastic. And the encouraging other behaviours also included reducing plastic use, but also energy reduction, writing to a letter to a politician, and signing a petition. So the interaction variables that we included to examine the relationship between those other variables included past participation in environmental events, and often with behaviours, past participation in an environmental activity can influence future action. So we measured past participation, but also past participation in community groups. And we measured environmental identity to see for the people who are really keen, they're already feeling like this is part of who they are. Does their experience differ from those who are new to this type of experience and don't feel that nature is a strong part of their identity? So, to the results. For the nature experiences, observable impacts, or that experience of seeing and experiencing nature and making that conservation issue real, increased willingness to take both personal action for yourself and also to encourage others. And this effect was constant across environmental identity, low or high, and across those different types of past participation. So my suggestion from this finding would be that making sure, if we're already designing citizen science experiences, really ensuring that that experience within nature connects the dots between this is nature, these are the threats that are happening, this is the solution, and this is how you can contribute to that solution. It's not just about going out and enjoying the beauty and the awe and feeling energized by nature, really making that experience real and connecting the dots for people. Next was nature connection. So being in nature made me feel more connected to it. And this is one that I think, as people who love the ocean, we all think that, oh, if you were just like me and you went out and experienced it too, you'd love it as well. It does help, but this finding wasn't significant until we added these interactions of past participation and environmental identity. So it did increase people's willingness to take behaviours themselves, but that effect was stronger for people who don't already participate in environmental groups, or for people who have a low sense of environmental identity. And this could be about novelty of experience. But the suggestion that would come out of that is to make sure that you're designing experiences that are adaptable to people who have a lot of experience in this interaction, or this type of experience, or people who have a low sense of environmental identity and haven't participated in this before. So for the social experiences, we found that learning from others, so I learned something new from talking with other people at this event, increased willingness to take personal action. And this effect was stronger for people who didn't previously participate in community groups. And again, the suggestion here would be to design programs that can cater for different audiences. So thinking about that effect of the newbies and the keen beans, I guess. The last result is about observing others and observing others taking action for reefs and coasts. And the impact of this social experience varied depending on someone's environmental identity. So for people who had a strong sense of environmental identity, this experience increased willingness to take personal action. And if they had a weak environmental identity, we found no effect. So it's possible that this is linked to diffusion of responsibility or bystander effect, which might be like, that's not something that I can do, I feel like I can do, or it seems like someone else is taking care of this, so I don't need to get on board. And again, designing activities to be inclusive, being explicit, we need all hands on deck and everyone can participate, and making those clear as to how. So in summary, my suggestions for designing citizen science programs would be to optimize these experiences, and they are already designed experiences. So we're already taking time to design something. And seeing as we're already doing that, we may as well optimize both this nature experience, that sense of wonder and awe and connection to nature, as well as these social experiences of having conversations with other people, practicing behaviours together, seeing other people model these behaviours. And that second point that I've repeated a few times is cater to diverse audiences. Know who's potentially going to be there. Know your demographics. In this study, I didn't mention this, but there was an increased willingness to participate if you were younger and if you were female. That's a common finding amongst other studies. But so consider the demographics of who's going to participate. Consider that they may have a range of environmental identities and past experiences. And that last point is one that I can't stress enough, is we're designing these experiences. If we want people to take away a message and do an action, then we need to connect the dots between this nature experience and this feeling of connection and wonder and awe, and the threats that's being imposed on these environments, the solutions that can solve that threat, and the behaviours and the ways that they can participate. So being really explicit in that whole arc of that story. This just background, this is a long-term collaboration with Reef Blitz, and this particular paper helped to improve the survey design. If you want to see more about that work, you can see it here. And a big thank you to everyone who participated and helped me in this work. And if you want to chat to me later, here are some other things that I would love to talk about. So yeah, that's it from me.
Any questions?
Yes.
When you say young women are really keen, how young is young and why? Also, that was really awesome.
That's a big question. I'm not sure the reasons behind it, but they tend to be a common finding across other studies in pro-environmental behaviours. Also, if you get volunteers to come to an event, they'll often be of a certain demographic. Yeah, maybe it's because we like helping. I don't know, it's a big discussion that could go down a very wide hole, but yeah, I'm not sure. It's just a common trend. Yes.
Hi. And thanks very much for the presentation.
Thanks, Helen.
I'm intrigued, given your method of sampling, lots of people that you had people with a low sense of environmental identity, and I forget the other low variable. You know, it would appear to me that people who go to these types of events are interested, unless they're friend draggable or something like that, or they're drag the kids. So I'm intrigued by that in itself, because it would seem like the sort of sample
would be all the keen beans, yes.
And also the implications. So design of the events for sort of people who are going to events, on difference from people who are already going to events. What about the rest of the population? Because people who go to these sorts of events are really a small key minority of the population living in the right sorts of places. You know, sort of thinking about my neighbourhood, my neighbours.
How to engage everybody else.
Look at everybody else.
I do have a population survey of willingness to adopt more general conservation behaviours, and my answer would be that there'll always be the keen beans who you can get to do certain types of behaviours that people are willing to do, and the harder the behaviour, the more you'll need those keen people. So in my other study, it was everyone was quite, or most people were quite willing to adopt these lifestyle behaviours, recycling, following quarantine rules, but fewer people were willing to do what I called civic behaviours. So buying land, putting a covenant on it, or writing to a politician, or attending a rally. So those things that might, in my mind, might have more effect on changing the system. So I guess one way would be to target specific behaviours to the people who you think will do them, And those people who already participate in environmental groups are probably where you'll find those people who will be willing to do those harder behaviours. And another way, there's a great paper by someone called Michi, and she has a behaviour change wheel. Some things people won't do, and you'll need different methods. So that might be policy and actually changing the system for it to be the easy option for people to do that thing. So we can engage people with citizen science events. We could have a whole discussion as to whether I think that's the solution or not. But yeah, it's one part.
The keyword there is systemic change.
Yes, absolutely. So we won't achieve systemic change with citizen science events, but it's a way to, it's one of the many tools in the toolbox to change behaviour at an individual level, and we'll definitely need other types of change, transformative change at a systems level. This type of event might help people to support that policy change that is needed to really get that step change to a different system that does achieve that effect of making the good choice the easy choice.
So Ian Tibbets has commented that pizzas work on students as inducements. I mean,
Absolutely, and I have managed to recruit people to my studies with pizza.
so, I guess I've looked a little bit at citizen science participation among recreational fishers who are most, and specifically game fishers who are the opposite of young and thin.
Yes,
quite literally. But I thought that there might be, like, I guess, more incentive to participate with the gamification, the tournament, the winning prizes aspect, but I haven't really found that. And I don't know if you've done any exploration in terms of like incentives and their role, and whether you think it's more like people's altruistic, I guess, feelings rather than them feeling like they're going to get something like a prize or a reward or a game. I don't know if you come across that in terms of stewardship.
There is a lot, so there's very many different theoretical models of behaviour.
Yeah.
And pro-social or pro-environmental behaviours do come under, they can have that altruism aspect or that sense of responsibility and doing it for the common good. As for gamification, I haven't done anything with that. I did hear an interesting discussion recently about making it relevant and it won't work unless people think it's relevant and really interesting and worth it. So like, I think a little while ago, it was a bit of a buzzword and everyone was like, oh, we could gamify that. Yes,
we had all those
for specific contexts and specific things. So yeah, I'm not sure, but it's an interesting idea. I know energy providers have done it in the past, and it often works. I think in that context, it worked if you were comparing you to your neighbor, so someone really close that you could be like, to get that competitive drive. I'm not sure, maybe you could do it on the boat with the fishermen and be like, who gets the most fin tags today? That might be one way. I'm not sure.
How have you looked at how long behaviour change lasts?
I haven't.
And how many interactions do you need to have with some people?
Yeah, not in these studies. It's just cross-sectional because that's the data we have. We did ask if we could follow up, but we didn't have enough. So that it's a more challenging research design, and it definitely should be the next step as far as moving from cross-sectional surveys to experiments and those longer term experiments where you measure a few times. I was chatting with someone yesterday and I think they had done that research and they said within a few months that would drop off. So I guess the lesson from that would be harnessing that in that window. How do you harness that enthusiasm or that willingness to actually get action or embed that action into a regular routine, or other ways of making that, if it's a one-off action like emailing a politician, that could be something more impactful that they only have to do once. And if you wanted to do that, then you'd do it within that window of opportunity. So yeah, depends on the action and yeah.
Yeah.
Yes.
Yeah, really nice talk. But I just wanted to ask, have you considered the socio-economic background of the basically your participants? Like, I mean, like, the general this thing is the community that is living close to the coast and which is having direct interaction in terms of places, their livelihood and other aspect with the ocean. They like they find it more relatable to like participate in like more stewardship and like protection and like conservation aspect, and also like in terms of economic strata and that kind of thing. So like then do you have plans or like have you considered that aspect of your participant to understand like the
Yeah, we did measure income as a proxy for demographic as wealth. And we did measure visitation to the reef as well. So as covariates.
was there any like significant trend that you could see based on the economic background?
On wealth? No. We held them constant. Age and gender were significant as covariates, but that wasn't our focus. We just wanted to hold those and make sure that wasn't messing with the other variables that we were interested in exploring. Yeah. Well done.
No, I think that's it from online. Yeah.
Great. Thanks everyone. Thanks online.
We have 17 people online, well, technically 15. I guess. Ian Simmons says, well done, exclamation mark, Main Street.
Can you see yours?
Right, just bear with me while I try and get, and just get rid of that. can't I?
Would you like me to do some clicking?
Yes. If you can do some clicking, I'll do the introductions.
Okay, we'll swap.
It's terrible. That's why I shouldn't be in charge.
You're doing great.
Okay, so thanks again, Emma, for your very interesting talk. Next up, hopefully, we've got Vicky Benion, who will be presenting her research on the ecological importance of ancient trees of, I meant to ask you how to say this, Avicennia marina in southeast Queensland. Large ancient trees hold ecological significance worldwide due to habitat provisioning for fauna, but this is not well studied for mangrove habitats. Transects through Moreton Bay's intertidal wetlands, locating and measuring large Avicennia marina discovered a non-regular pattern of locality with ancient trees mostly found in the seaward sections of forests, providing an important microhabitats for fauna. Ancient A marina therefore hold great ecological importance for faunal habitat provision in urban areas. So please join me in welcoming Vicky.
Welcome, Vicky.
Thanks, Ian. Yeah, all right. We'll just get straight into it. So I'm just going to talk about some what we're calling ancient mangroves around Moreton Bay. So what's done? We're moving forward.
Yeah.
Right. So I'm just going to start on different side steps. So large terrestrial trees. There's loads of these basically big studies that are looking at the ecology, distribution and conservation of and management of large old trees, but these are only looked at terrestrial. So there's no literature here and there's no even mention about the word mangrove. But one thing they do find is that once large trees are lost from an ecosystem, they're hard to replace and recover So that's one big point, and a lot of this, as said, is terrestrial. We moved on from that one and found that the global decline in large old trees, again all terrestrial, says that it's like losing a large keystone organism. So like losing a large cetacean or a shark or a whale from an ecosystem is like losing a large tree, something that a lot of people probably don't think about. But they do find that more research needs to be done on large trees, including the threats to them. And they're known to be, they form these unique ecosystems. So more, again, large terrestrial trees, there's loads and loads of literature. No one wants to think about mangroves, but so ancient trees, they're irreplaceable. They're keystone organisms. One even found that they still grow, the largest of their trees still grow. And another one found that looking at the size, the largest 1% in the ecosystem are sort of the large trees, or they're putting things like a 60 centimeter diameter at breast height is a large tree. And others found that there's a lack of large trees within this, within the data sets worldwide. And just for an example, this one here is, they said one of the largest trees in Australia. It's a red gum in South Australia, 3.7 meter base diameter, which is quite old, and they think it's about 800 to 1,000 years old. Now, there is a little bit of large mangrove literature, but it's very limited. So back 37 years ago, they thought the largest mangroves were about 50 centimeters in diameter at breast height. And they were found to produce more flowers and seedlings. One study here, even in Moreton Bay, found that microbat activity was higher within old forests. But these are old forests with older mangroves. There wasn't specifically any detailed information about the mangroves themselves. And one even found that they grow slower in high salinities. And that's a more recent study. Again, there's limited studies on and knowledge about these ecological significance of these ancient mangroves. So you're wondering why ancient mangroves or why care about them. So they play these really big, important in the ecosystem. They hold these, they have these hollows that form throughout them. A lot of fauna can live in them. They sort of squeeze out younger ones from coming through, and they just dominate these massive ecosystems. We pulled out ancient, the Britannica Dictionary says that it's very old, having lived or existed for a long time. So we have used this as our example and why we've been calling them ancient. And they have these really big the pneumatophores of these mangroves they help bind sediments in them. The bigger trees obviously can then filter more nutrients and sediments. They are known to contribute more flowers and seeds, having larger trees, large canopies, big habitat provision, and bigger mangrove, bigger carbon sequestration. It's all the talk at the moment about this blue carbon and how mangroves can sequester so much carbon. Bigger mangrove, bigger carbon. Now, only recently, I was like, why is there no literature on these big trees? And it only got brought to my attention a little while ago. It's because Moreton Bay doesn't have any tropical storms. So yes, trees grow here and the mangroves grow here, but we don't have these cyclones that come through every 10 years that knock the trees down. So for instance, over in Florida, they get these cyclones every 2 or 3 decades and they knock the trees. Therefore, they're regrowing every few decades. Moreton Bay hasn't had any tropical storms. So we actually don't have the issue of these mangroves dying and having to regrow every 50 years. So just in general, for those that don't know, catchments in Moreton Bay, about 15,500 hectares of mangroves, 12,800 is Abyssinia. Range of geomorphic settings, we've got the rivers on one side, oceanic islands on the other. Well documented through aerial mapping. So they've been looking at all this stuff. This is how people do it. They look at maps, come up with these things and say there's mangroves there. But so from what I'm interested in, you can't tell me what's in under that canopy. You can't say whether they're small or large mangroves because you're just looking at a canopy and they all overlap. And when you're in there, you can tell that they overlap. So what I've had to do is I've had to walk through this. So we've had to walk underneath and actually measure these mangroves and see what's there. measuring their canopies from underneath again, all doing transect tapes. So basically just going throughout any accessible parts that we can reach on foot that's safe to get to. And we've just been GPS plotting some locations that we're doing like basal, like just transects with basal plots, measuring mangroves, just canopies, hollows, the presence of fauna around them, whether they're knocking the seedlings out, whether there's any younger trees coming in through as well. Some trees I've been measuring the growth on using these electric dendrobands and using comparison to smaller trees to see if they are still growing here in Moreton Bay or not. So a range of little things that we've been looking at, all in Moreton Bay. And I'm just going to show you a snippet of what we've come up with at the moment. So yeah, as I said, doing these basal plots, looking at hollows, and what we've called ancient here for Moreton Bay is a tree that itself, where at least one stem has a DBH of above 60 centimeters. So as you can see here, this tree here, 3 stems, but that middle stem is 70 centimeters DBH. So therefore it is still an ancient tree because it is large enough with one stem. The base diameter there is 2.5 meters for a base diameter as well, just to note that. These are quite large trees. So aerial distribution of mangroves, as you know, in the blue there, they've got a wide span throughout the whole of Moreton Bay, mostly covering all the rivers that are coming into the bay, and a lot down sort of North Stradbroke, and a lot of islands down on the south are covered in mangroves as well. Haven't been able to access all of these, but we plan on doing this in the future. So basically I've done about 93 random plots so far. And from those, we've come up with 21 large trees. And that is just from aerial imaging, picking GPS locations and going to them and doing the transects. We've also been doing time searches on top of these, but of this, all of them are found in the fringe. So that's the landward side, that's the seaward side. And those pink dots there represent where we've located them. From the ones that we found in the middle area, most of them are sort of the larger trees that are actually decayed in the middle and have still got some remnants on the outside. So these are still ancient trees. They just don't have the large stem. They've got the large bole, and you can see that they're all connected underneath. It was significant that all of these areas of the large trees are away from Brisbane City itself, the star here. And we still have areas to search. The blue dots are the ones that I'm still planning to get to when I have some time to keep searching. But it must be known that pretty much every area that we've gone to, we've found at least one large tree. And it's actually not thinkable that you just don't realize just how many there are and exactly where they are. Through measuring different things, the canopy extent of a tree, so measuring on 4 cardinal directions, you find that these large trees have a larger canopy, therefore they're collecting more rainfall, they're supplying a bigger area for other fauna to live in. They've got more stems, so we've been measuring how many stems they have, and so some of these large trees go up to like 10, 12 stems, and one of these is still larger than 60 centimeters in diameter. Some small trees do have large tree, like a few stems as well, but they also they're just massive trees. Measuring hollows as well, so almost all of these large trees have hollows in them that one of them you can fit a person into, but they form these unique habitats that fauna can live in, protect in, roost in, and it must be known that these younger trees also have quite a large proportion of hollows in them. This sort of stuff just people don't document. You might think it and know it, but it's just not well documented. And one of the things that we've been looking for is bats. It's not actually put in the we're trying to put bats in as a wetland indicator species because it's not currently on the Queensland government register as a wetland indicator species. So we're trying to find bats. We did find some, whether this works. So we're in a hollow in one of the mangroves out at Tinchitamba. So these are tiny, just little micro bats. In a hollow. Come on. Should have only been small. Yeah, there. Yeah. All right. So yeah, there is a few bats, but they're hard to locate and do other things. So moving on, we found looking at some growth in these mangroves, which is sort of one of my big key things at the moment, and I'm enjoying looking at mangrove growth. So you can have these electric dendrobands. So they you connect them to the tree tightly, and they're electric, run on a long-term battery, and you can measure the growth of these mangroves on a half-hourly interval. So every half hour, it'll take a little increment as to whether it's moving, whether they're swelling it, like shrinking and swelling of a tree during the day. And then long-term, we put on these manual ones that just you come and measure the little growth increment from where you've scored it to see throughout time what's happening. And believe it or not, these old trees are still growing. So this is from 6 months on some trees, and the ancient ones that we had the electric dendros on are growing at almost double the rate of the young ones. I've done this as a basal area growth, the circumference growth. So they're putting on almost twice as much mils. And now you might look at that and look at it and be like 1 mil a year. So this is 1 mil a year in circumference growth. And now I'm going to compare that to an ancient tree, and I'm saying that these circumferences are like 180 centimeters, and they're growing at 1 mil a year. So how old are these trees really if this is their growth rates? And now I'm going to pull in that growth rate. And that growth rate is coming in from long-term studies that we've done here in Moreton Bay. And the growth rate of all Abyssinias is around 1 mil a year. Just on another thing in the progress at the moment, we've been looking at the multi-stem mangrove growth. So a tree that has 10 stems on itself, we've connected these electric dendrobands, and we want to know if they're all growing at the same rate. So this is currently in progress, and they're out there in the bay in a hidden location. And this should come up in the next year as to what's happened with that. And again, just to compare, so the red dot here is our Abyssinia. And yeah, so it's just over 1 mil a year in circumference growth. Rhizophorus stylosa, as some of you may know, the red mangrove with all the prop roots, they're coming into the bay in more higher density these days, and their growth rate is a lot higher than the Abyssinia. And in comparison to these other terrestrial tree species, mangroves are growing at a much slower rate. A different way to date mangroves is to carbon date them. So some of you may have heard a few years ago, this mangrove was found up in the Gympie region on the Mary River and was carbon dated to about 700 years old. It was quantified through Norm Duke, who's measured the tree as well, and he thinks that it too was about 700 years old by using the diameter of the base of the tree and thinking it was, and using his length to say that.
Can the people on the chat please mute your mics? Thank you. Colin.
So as an example of ages and growths of these trees, so this is a tree that I found up on near the Caboolture River. It has a base. The base diameter itself is 175 centimeters. Or the circumference around it was like 5.5 meters. Now, if I was to use that, how old they are in comparison to that other tree that we know was 700 years old, this tree is about 450 years old. Again, carbon dating is very expensive and it's not very accurate. So we're looking at trying to make a record to know how old and large these trees are. If I was to use this huge stem here, that itself is 83 centimeters in diameter. Its own circumference is 2.5 meters around. Now, using a over prediction of 4 mils a year in circumference growth, and I'm over predicting by double, I'm saying this tree is about 650 years old. Again, this is all preliminary work, but again, I'm using an over prediction of the size and the growth rates, and possibly we're looking at over 600 years old. The tree I showed you earlier, base circumference 2.5 meters in the diameter is 2.5 meters. So it could be predicted at about 500 years old, or that middle stem that is 70 centimeter diameter at a 4 mil growth rate could be about 550 years old. So again, more trees that we've found. Unfortunately, I don't have one of this one closer, but it was quite a large tree and had only 1 or 2 stems in the middle and was about 550. And more at Halloran, where they're about the same age. These are really large trees. And a comparison of the two that I've been talking about, this diameter at the base of the tree and the diameter measured throughout these breast heights, there is quite a strong correlation between the two. And we will be looking at, like, in the future, whether you can just measure the bole of a tree, which is at the base, and that can predict your breast heights instead of having to measure 10 dBHs. And the reason you've sat here and listened to this talk, because more and more of this is happening in Moreton Bay. This is one large tree that we came across 2 years ago that had actually fallen down in a storm. And these things need to get more recognition and more knowledge, because if this keeps happening, then we're in trouble. And we possibly need to think about a different way of looking after the mangroves. So, thank you.
Any questions online?
No, not yet. It's just a
Trees.
comment of mangroves, exclamation marks. Some excitement about mangrove.
I have a question.
Oh, hello.
Sorry. Yeah. So, Vicky, great talk. Thank you very much. It's now opened my eyes about what the hell you do, and also about the significance of these large trees. My question is about the root system. So, in terms of carbon accumulation by the tissue, compared with a terrestrial tree that has its roots, I guess, doing nutrient things in an oxygenated environment, versus this sort of tree that has roots for respiration as well as for nutrient gathering, what's the sort of ratio of biomass between the root system and the above ground biomass for this sort of system? Do you know? I mean, has anybody done anything? Okay, yeah.
I don't know, but I think you should be talking to a guy called Jay Hill, and he will give you
right.
6 months the biomass comparisons of mangrove roots.
Okay.
To above ground, which is something that we've been done in the field 2 years ago.
All right, cool. Can I have a follow-up question?
Cost you.
All right. What's pizza? What's with the you know, those funny mangroves down near Toondah Harbour where they kind of seem to have a growth level and then there's like a secondary growth level? What's that about?
Yeah. We think it's got to do with the water levels there. So the water, as you know, the water comes in and covers the first level. So they've grown taller to go to the next level. And there's thoughts when we go and visit those mangroves that they're actually very old indeed, because you can tell by the wood that they're very old. But they're actually short, fat and stumpy because of the wind that goes through those areas, and there's no wind, like something to protect them. And they're all on their lonesome. So they're like little short, wide, stumpy things.
So they're like they're like origami trees or something, are they? Origami trees?
Yeah. Like they can't grow tall because they would get like knocked over with the waves as the tide comes in and out.
Yeah, gotcha. All right.
Yeah.
Really cool. Thank you.
Questions from the chat on this. Oh yeah, you go first.
So how many big trees would you expect or want to find in a mangrove area? Do they have certain?
No, a lot of them are together. So like once you find one, you keep moving through the forest and you'll find more along there. But a lot of them are in reserves. I sort of missed that out. A lot of the reserves have a lot more in them. And they're more in the back areas of reserves as well. But a lot of the coastlines, you know, our coastlines are absolutely covered in mangroves, and some of them are just right there in front of your eyes. You just don't really take notice of the fact that they're so big and stumpy. But yeah, I expect that I will keep finding more and more and more throughout time as we keep doing these.
And is there much protection for these habitats on the coastline?
Not protection themselves, because they're all exposed to the oceans and the waves. And legally, yes, everything's protected. So you're not allowed to touch, to be able to destroy mangroves or coastal wetlands, you actually have to put in government like permissions. And in Moreton Bay itself, you pretty much can't touch anything. And if you just start taking down mangroves, then you're in for a loyal dispute. So.
Yeah. Why does that happen?
Why? So this is the next chapter. One of the chapters on my thesis is looking at what has happened here. And this happened following a large week of storm. So there was increased rainfall, increased sea level, and increased wind through one of the Cleveland creeks. And this has caused the tree to get overburdened, too much water underneath it. And we think it's just absolutely caused it to topple. So there's 3 stems of that tree and it's just snapped in half. And I've been following, for 2.5 years, I've been following the elevation and the recovery of this area. And halfway through writing up a manuscript on it.
More storms.
More increased storm activity affects trees and it just waterlogs it and then causes the trees to lose stability.
I might ask a question from the chat from Abigail Natush. Did you see any change in growth from last year due to the floods? How were the mangroves impacted?
One of the first things we sort of say is if you look out from UQ along the river and you see that all those mangroves defoliated throughout time. So with floods, all these mangroves need air to breathe. And with the floods, especially along the Brisbane River, 3 days of no air causes them all to go into stress and they defoliate. They came back after 2011, they'll come back again. Some of them I see are still defoliated. But throughout storms, so mangroves need fresh water. They actually need rainfall to grow. And there's a strong correlation through all mangrove growth that increased rainfall, increased growth. So yeah, increased storms, but it's very delayed. There's like a 3-month growth delay of rainfall.
Abby says cool talk. And very helpful.
So you found the majority of old growth trees to be fringe side of mangrove forest.
Yeah.
And that it technically places them at higher risk of sea level rise,
Yeah.
right? And
Yeah,
so
it
that kind of
does.
feeds back into your theory for this next
Yeah.
chapter of them being waterlogged. I
Yeah.
guess.
Yeah, so waterlogged. So mangroves can accrete sediment. So a big part, again, of plug for the PhD is looking at sediment accretion and elevation of mangroves. So they're actually able to keep accreting sediment. And at some point, the deltas will become too big to accrete sediment. But for Moreton Bay itself, this is going to be like tens of thousands of years. But these mangroves just keep accreting sediment and popping it onto the sand as sea level grows.
Yeah.
So sea levels rise at 2 to 3 mils a year. These mangroves are packing on 4 mils a year in elevation rise. And it's also, there's another theory on the roll that they're possibly moving landward. So if this tree puts down another stem landward and grows, and then so they're just going to keep moving backwards with sea level rise as they keep going. Yeah.
Till they reach a road.
Yeah, and then they'll reach roads and then they'll reach houses and then the whole thing will be blown
I guess
out.
then still being on the fringe side of the forest though, they're still at high risk in terms of from storms and stuff
Yeah.
like that, right? So they're not gonna have all
They're
of
not
that
gonna have-
wave break before
Yeah.
it actually hits them.
Yeah.
Okay.
So
Thank you.
So from Devon Rowell in the chat, we have amazing research, exclamation mark. Any idea why the ancient trees are growing faster than the younger one? I assume trees are a bit different than.
because so that goes back to our big rainfall question, because they're capturing more rainfall in the leaves and the stems, and then that's channeling down to their main body of thing, and they're capturing and they're holding more water. And of course, then they're also capturing more nutrients in through the water that's coming in through the seawater. So therefore, the larger trees, larger area, larger growth, it's all pretty much linked to that sort of stuff. And their root systems are massive. So Abyssinia root systems for these large trees would be expected to be about 50 meters wide. So that's something that we've been doing measurements on. And yeah, how wide these systems really are, because it's hard to track. So they're just absolutely dominating the whole area.
So another question from Fabio Cortez. Lots of questions. Very cool talk. How old do you think these trees can get? Along the same lines, do you have any idea why most of the large trees seem to be around 500, 600 years old?
I think it becomes a point, as you saw, where they sort of, the middles start degrading completely and they start just having outside stems. So, and then but the trees themselves could stay for thousands of years as remnants of older trees, sort of just but smaller. Again, it's really hard to date these things, and the significance levels that you get from a dating is like plus or minus 200 years, which is almost useless to this sort of work. Around 500-600 years, I think it's just because I haven't found those and I was trying to put in a lot that are higher. I do have some smaller trees. A lot of them are actually like younger trees as well, 300-400 years old. There's a massive variety of them. I just haven't come across any yet, or I didn't have the pictures of the ones that I did find that are larger, which I need to go back and get.
So I think there's 2 more in the chat. Do we have any more from the group?
Yeah.
I just wanted to ask, like, is there a possible competition between large trees and small trees, like around the vicinity?
Yeah.
Given that large trees are going faster, so like you are explaining that there is a higher rate of nutrient distinct from the roots and the rainfall distinct. So, is there competition from the large trees to the trees from the same species, as well as other coexisting species in that area?
Yeah. So you can sort of see from this picture here that there's no young trees in the background at all. So large trees don't allow them to sort of, even if they settle, like you get the seedlings settling, even after a year or two, they tend to sort of be able to push them out by not allowing them to stabilize and grow in the sediments. So you'll just find that, large trees, they just absolutely dominate the areas. And sometimes you'll see like a large tree and then like a circle around them where they just completely block out anything from settling. And then you'll see like all these younger trees around them.
So, sorry, a follow-up question. So when, for example, when we are suggesting mangrove restoration along a degraded coast or something like that.
Yeah.
So I'm like, the general idea is to like plant as many seedlings as possible in the area to increase the number of plants.
Yeah.
But like when we find that like large trees over a period of time, like, you know, they are having more carbon sequestration, like more carbon assimilation, more nutrient and more circulation and more recycling things. So like if this kind of studies can be used to basically provide guidance and suggestion towards restoration, that, for example, a species like Abyssinia marina should be planted across far distance, so that like eventually on a long term, you are having better results of your restoration efforts.
Yeah, so I mean, a lot of restoration is another big topic to talk about. But a lot of things are like the more planting that you do, yes, you have higher success rates. And the right areas to bring in, it's a big another topic altogether, sort of thing.
All right, good. 2 quick but good ones from the chat. Well, I don't know about quick, but anyway, they're good questions, so I want to read them out. So from Jan Aldenhoven, we have great talk. Are there studies overseas that show a decrease in the fauna when mangroves keep getting knocked over by storms, or decrease in particular species such as those microbats reliant on hollows?
Thank you, but not that I've looked into. There's a few species that are known to be better pioneers of these knockout areas. So like, for instance, when all those defoliated and trees that got knocked down in Florida in that. There's one species that isn't in Australia, but it's a very good colonizer, and it comes in and just colonizes the area in about 5 years. Something that we don't have here in Moreton Bay. These areas can take like 20 or 30 years to get recolonized. And no, I haven't looked, sorry, at any issues with fauna losses in these big areas. Something I should look into. Thank you.
And then we'll just try and squeeze in one last one from Colin Scobie. Did you find any significant oyster recruitment on the mangroves? And he also wants to know where.
Oysters are all over the mangroves, mainly on the islands, and but not on the rivers, I'd say, with the oysters. But they do live everywhere on those mangroves on the islands.
Well, maybe we'll let you off the hook and wrap it up.
Thanks, Laura.
There is another question for you online, but they need to get back to and we have yeah.
Thank you.
So
Thank you, Tracy.
thanks very much, Vicky. Okay, so thank you to both our speakers, Vicky and Emma, for presenting your research today, and also to all our in-person and online attendees. And thank you to Laura for managing the chat. So just to let you know, in 2 weeks, we'll be hosting a special seminar here and on Zoom at 10 a.m. on August 22nd. And our special guest speaker is Dr. Alexander Brearley from the British Antarctic Survey, presenting his research using underwater robotics to understand Southern Ocean circulation and change. So I hope you can join us for that seminar. Our next HDR seminar is scheduled for September 6th with 2 excellent speakers booked in. Don't forget our lunchtime meetup before the seminar, where you can meet, chat and network with other fellow HDR students. And if you would like to present your research at one of the upcoming postgraduate seminars, please get in touch with us. And if you're interested in helping out on the CMS HDR committee with events, please also get in touch as well. So thank you again. Looking forward to seeing everybody next month. And have a fabulous day.
Have a symposium
Oh,
on the 25th of September.
okay. Has details been sent out yet?
We just put it in the chat.
Okay. Okay, good. So
That's everything.
yes,
So
that's
many great things
that
being
is
done by the CMS HDR committee. We're going to go on.
excellent. Thanks very much. See you next time.
Bye, you. Everyone.